Hello everyone, welcome to our online distance learning. So, I am Teacher Noel as your math teacher. Are you ready to learn and gain more information? Okay. So, I think you are excited to learn and gain information so that you can apply this topic or our topic in your real life situation. Are you ready? Okay, so I am going to present two pictures. Can you identify what are those pictures? Very good. Okay, so the first picture represents a group of transportation vehicles, while the second pictures represent a group or a set of animals. Now, what did you observe from the two pictures? Do you have an idea about our topic for today? As you can see from our given pictures, we are talking about group or this is what we call a set. As you can see, there's a group of cars or there's a group of transportation vehicles. Another is a group of animals. Now, that is our topic for today. But before we discuss about sets, let's have some objectives of our lesson. At the end of this lesson, you will be able to illustrate well-defined sets, subsets, universal sets, null set, and cardinality of a set. Another one is to illustrate union and intersection sets and the difference of the two sets. Now, let's define what is a set means. When we say set is a collection of objects or things. Each object of a set is called an element or a member. Just like our given pictures a while ago. There's a group of transportation vehicles and those are what we call elements. What are those? There's a car, buses, boat, airplanes. Those are what we call elements. Another one, set is usually denoted by capital letters and its element by small letters. Then it is enclosed by a bracket or this is what we call braces. For example, the items you wear. Can you give me what are those items that you can wear in every day? We have hat, shirt, jackets, pants, and so on. There's a lot of items you can wear, right? Okay, so let's have parts of a set. When you say parts of a set, as you can see from our given example, we have a numbers 3, 6, 9, and 12. So 3, 6, 9, and 12, this is what we call the elements in a given set. Now, there's a three dots after the three elements. This three dots is what we call ellipsis or goes on forever, which means infinite. When we say or when we have three dots in our given sets, it is not countable. Ibig sabihin, walang katapusan. Next one is the set of brackets or braces. Okay, so that is the curly parenthesis at the side of our elements. Did you understand? Okay, very good. Now, we have two methods in a given set. This is what we call the raster method and the set builder notation. First, let's talk about raster method. When we say raster method, a way to show the elements of a set by listing the element inside the brackets. What does it mean? So, in raster method, there's a given problem where you are going to find the elements. For example, when we are writing a set in raster form, let A is the set of natural numbers between 3 and 7 exclusively. What do you mean by exclusively? Okay, so 3 and 7 hindi kasali sa mga hinahanap nating natural numbers. So, how can we find or how can we write this equation in set of raster form? So let A is equal to the bracket or braces, then we have element 4, 5, and 6. So 4, 5, and 6 are the natural numbers between 3 and 7. Did you understand? Let's have another example. For example, we have x or the element of all x such that x is a color of the rainbow. Do you know what are the colors of a rainbow is? Okay, so we have the what we call Roy G. Biv or the red, orange, yellow, green, blue, indigo, and violet. So that is raster method. There's a given problem and you are going to find the elements of that given problem. Okay? Now, let's have the set builder notation. For example, there's a given the set of all x such that x is greater than 0. So this time in set builder notation, you are now going to find the problem. But the given is the element. Let's have an example. Okay, so let's represent the following set in set builder form. For example, x is equal to, we have Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. Okay, so the set x contains all the days of a week. Therefore, if we are going to write the set builder form, we have x is equal to the set of all x such that x is a day in a week. Can you observe the pattern? Yes. In raster, we are looking for the elements. But in set builder notation, we are going to get or we are looking for the given set. The vice versa of raster and set builder notation. Okay, so let's have one more example about set builder notation. Okay, so we have an element of January, February, March, and so on up to December. Can you identify the set builder form or notation of this problem? As you can see, the given problem, we have January, February, March, April, May, June, July, August, September, October, November, December. So we have month in a year. Therefore, we have x or the element of x such that x is a month of the year. All those given elements are what we call months in a year. Did you understand? Okay. Now let's talk about well-defined set. When we say well-defined set, it means it must be absolutely clear that which objects belong to the set or which does not. So when we say well-defined set, make sure that the given objects is under in that given set. Now, let's try to identify if the given problem is under well-defined or not. A set of numbers from 1 to 10. Can we say that a set of numbers from 1 to 10? What are those numbers? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can we say that a set of numbers from 1 to 10 is a well-defined? Yes, it is a set because we can list all the numbers from 1 to 10. We can write the numbers from 1 to 10. Or we can list the set of that numbers from 1 to 10. How about a set of smart students? Another is a set of generous students. No. Now, can we say that this is an example of well-defined set? No, it is not a well-defined set. Why? Because from the word smart and generous, smart and generous cannot be defined or measured. Those words are what we call relative terms, meaning it can change from one individual to another individual. Did you understand? Let's have another. A set of all letters that comes after T. Can you identify those letters after T? Okay, so we have U, V, W, X, Y, and Z. Can you say that it is a well-defined set? Yes, very good. This is a well-defined set because we can list the letters after T. Do you understand? So now let's have the different types of a set. What are those different types of a set? The first one, we have the empty set, equal set, subset, and universal set. Now let's talk about empty set. I have here given example. We have set A where the elements are 1, 2, 3, 4, and 5. In set B, we have 6, 7, 8, 9, and 10. What did you observe from our given example? For the example in set A, we don't have common numbers from set B. Also, in set B, there's no common values or numbers in set A. So, since there's no common values or common numbers in both sets, this is what we call empty set or null set. So, when we say empty set or null set, two sets are disjoint if they have no elements in common. Meaning, from set A, the element of set A, there's no common element from set B. And in set B, there's no common element in set A. Okay, next. Additional types of set is what we call the finite and infinite set. Let's talk about finite set. From the word finite. Okay, so when we say finite, it is countable. And finite means a set that has a finite number of elements. Meaning, we can list all the numbers, objects, or things in a given set. For example, the set of whole numbers less than 5. Can you give me what are those numbers? Or whole number less than 5? Okay, so the correct answer or the elements are 4, 3, 2, 1, and 0. So that is what we call finite set, countable. We can list or we can write the elements. Another example, the set of primary colors. Okay, so alam ko na alam nyo primary colors when you are in elementary. What are those primary colors? Okay, so the elements are red, blue, and yellow. See this is also what we call finite set because we can list the numbers or colors Now, let's have infinite set. If there's a finite, there's infinite set. When we say finite, it is countable. Now, in infinite, a set whose element cannot be counted, or meaning to say, not countable. For example, the counting numbers greater than 10. What are those counting numbers? The elements are 11, 12, 13, 14, and so on. We can write all the numbers. If we are going to write all the numbers, ay nako, hindi tayo matatapos. Naintindihan? Next, equal set. Okay, napakadali. Is equal set. When we say equal set, two sets are equal if they have equal numbers and similar types of element. For example, we have in set A 1, 2, 3, and 4. In set B, we have an elements 3, 1, 4, and 2. What did you observe? Okay, as you can see, in set A, there's a common element in set B. Where in set A, there's a 1, also in set B, 2, 3, and 4. So all the elements in set A, the same to the elements in set B. Therefore, we can conclude that A is equal to set B. Or we can say that set B is equal to set A. Did you understand? Okay. Now, let's have subset. When we say subset, all the elements of A are elements of B. For example, in set A, we have 1, 2, 3, 4, and 5. In set B, we have 2, 4, and 5. What did you observe from both sets? Okay, so there are common elements. We have 2, 4, and 5. Now in set A, there's a number 1 and 3 does not have in set B. Make sure in subset, there's the same element in both sets, just like in our given example. So we are going to eliminate 1 and 3 so that we can see the common element. Now, can we say that set A is a subset of B? No, but we can say that B is a subset of A because 2, 4, 5 in set B have an element in set A. But we cannot say that A is not a subset. So meaning A is not a subset of B because there's an element 1 and 3 does not have from set B. Okay? So last, let's talk about the universal set. When we say universal set, contains all the elements of other given sets. The symbol for denoting a universal set is letter U. Take note, universal set denoted by capital letter U, while in union set denoted by a symbol like U but not U. Okay, now let's have an example. For example, we have 1, 2, 3, 4 in set A, 2, 4, 6, 8 in set B, and 3, 6, 9, 12 in set C. Now, if we are going to get the universal set of these given numbers, you are going to get all the elements from a given set. So the universal set is equal to 1, 2, 3, 4, 6, 8, 9, and 12. Did you follow? Okay. Do you have any question? Yes. As you can see, there is two numbers or there are repeating numbers. We have two twos, we have two six, two four, and two three. Bakit hindi natin sinulat ng tagdadalawa? Under the universal set, any repeating numbers we're going to write as 1. So, ibig sabihin, hindi na mauulit yung mga numbers na sulat natin na mga nauulit. Okay, so let's have another example. From a given box, there's a word which is 1, 2, 3 inside the box but not inside the circle. Now, inside the two circle, we have chicks 4, 5, and 7. Now, if we are going to get the universal set, just simply, just like what I said, get all the elements. Get all the elements. So, we have 1, 2, 3, 4, 5, 6, and 7. So, that is what we call set. Did you understand? Alright, so that will be our lesson for today. Again, I'm Teacher Noel as your math teacher. Have a nice day.